Everybody wanna be a dope boy. Everybody wanna be a coke boy. Everybody got a job. Everybody get money. Everybody.
Paul for 0.15 seconds. What is the change of momentum of Paul? We first have to use force is equal to mass times acceleration to find our mass. So we plug in our values. 580 newtons is equal to mass times negative 9.8 newtons per kilogram, which is the acceleration of gravity. To find that mass is equal to 59.2 kilograms. Then we use our equation impulse is equal to change in momentum to get also forces times change in time is equal to mass times change in velocity. To get 580 newtons times 0.15 seconds is equal to 59.2 times change in velocity. And then we get 87 newton seconds is equal to 59.2 kilograms times change in velocity. And then we divide both sides by 59.2 and we get our change in velocity to be 1.5 meters per second. Then we use our change in momentum. P is equal to mass times velocity, and then delta P is equal to 59.2 kilograms times 1.5 meters per second. And we get our change in momentum to be 88.8 kilograms meters per second. A medicine ball rolls at 3 meters per second and hits a stationary ball. The two balls now move as one. The moving ball has a mass of 7 kilograms and the stationary ball has a mass of 0.5 kilograms. The momentum conservation diagram just shows the situation of it at the before situation where they're apart, and the after situation now they're moving as one. We found the final velocity in our equation by using the equation mass 1 times velocity 1 initial plus mass 2 times velocity 2 initial is equal to mass 1 plus mass 2 times velocity final. And we plug in our numbers and we find that the final velocity is equal to 2.8 meters per second. And we found that the type of collision is inelastic collision because they stick together.
Another medicine ball rolls at 2 meters a second and hits a stationary medicine ball. It bounces back in the opposite direction and the stationary ball stays put. The ball moving at 2 meters a second has a mass of 2 kilograms, and the ball that remains motionless is 4.5 kilograms. What type of collision is this? We figured out that it was an elastic collision because the balls bounce in the opposite direction and they don't stick together. Next, we figured out the final velocity of the ball that bounces back. We used the formula m1 times v1 initial plus m2 times v2 initial equals m1 times v1 final plus m2 plus times v2 final. We plugged in the numbers and got velocity final equals 2 meters a second.
Medicine ball has a mass of 0.5 kilograms and it compresses a jumping pad 0.3 meters. How fast will the ball go when it's released? And our K constant is 100 newtons per meter. So first we use our elastic potential energy equation is equal to 1/2 K constant times x squared, which is our distance. And then we do elastic potential energy is equal to 1/2 times 100 newton meters times 0.3 meters squared. To get our elastic potential energy is 4.5 joules. And since energy can't be created or destroyed, joules, which is energy, gets transferred into kinetic energy. And we use our kinetic energy equation is equal to 1/2 mass times velocity squared. And we plug in our numbers and find that our velocity equals 4.24 meters per second when the ball releases from the jumping pad.
A medicine ball with the weight of 2 kilograms is rolling down a slope path. The ball is moving at 2.5 meters a second. What is kinetic energy? So we use the formula Ke equals 1/2 mass times velocity squared. Ke equals 1/2 times 2 kilograms times 2.5 meters a second squared. We figured out that Ke equals 6.25 joules.
Kinetic energy is energy in movement.
Jack is bench pressing a 9 kilogram bar. What is the gravitational potential energy when he lifts the bar to 1 meter above the ground? Okay. Gravitational potential energy is the energy of an object above ground. So we use the formula GPE equals mass times gravity times height. We plugged in numbers 9 kilograms times 9.8 meters a second squared times 1 meter. We figured out that GPE equals 88.2 joules. Christian, with a mass of 66 kilograms, pushes on Jack with a mass of 77 kilograms. Who experiences the greater force? In this situation, both experience the same amount of force. This is due to Newton's third law. For every action, there is an equal and opposite reaction. So if Christian pushes on Jack with 700 newtons of force, then Jack would push back on Christian with negative 700 newtons of force. A medicine ball is rolling on a frictionless surface. Describe the course of action of the ball once it moves on a frictional surface. The ball will eventually come to a stop because of friction. In Newton's first law, an object in motion will stay in motion in a straight line and at a constant speed unless acted upon by an outside net force. In this case, the friction is the outside net force, which will slow the ball and bring it to a stop. Two dumbbells are placed 1 meter apart. What will happen to the attractive force between the two when you triple the mass of one dumbbell? So we use the formula F equals G times the first mass times the second mass divided by R squared. And we plugged in 3 for the first mass. And the force we figured out was 3 times the original force. So we also figured out what will happen when you double the distance between the two dumbbells. And we use the same equation, F equals G times M1 times M2 divided by R squared. And we plugged in 2R squared. And we figured out the force would be 1/4 the original force.